Welcome back, another week, another gas lesson, and today in part 7 we are diving into multiplayer. We'll look at how Unreal Engine handles networking in general with things like replication, RPC calls, and prediction, and we will learn how gas builds on top of that. Then we will upgrade our weapons manager component from last part to work in a multiplayer environment. We will also fix the networking issues with our dash ability, and while doing so, you will learn a lot more about how networking works in gas. So let's jump right in. Unreal Engine uses a server client setup. That means that in multiplayer, there are multiple copies of the game running on different computers. One of these computers is the server, which can also be a player, or it could be a dedicated server. All the other computers are called clients that are each running their own copy of the game and connect to the server. Now, with multiple copies of the game running on different computers, how do we keep things synchronized? Well, that's where authority comes in. In Unreal Engine, the server is also called the authority. This means that the server is responsible for dictating what the state of the game looks like, and all the clients update their own copy based on what the server says. That is what replication is. Replication just means that the server continuously synchronizes the values of all replicated actors to the connected clients. For example, a replicated box moves on the server, then all connected clients see the box move. This is because the box is replicated, and most importantly, the movement properties of the box are all set to replicated. But if a client tries to move the box, this only happens on their copy and no one else sees it. So how do clients take actions that everyone else sees? This is where RPCs come into play. Clients request to do an action on the server using what's called an RPC call, and this only runs on their own copy on the server, because the server has a copy of all the connected players. So you set an event to run on the server, then the server runs that event, and then because this event ran on the server, all the other clients see it. Well, what about latency? If every time I do a simple action like move, I have to tell the server, hey, I want to move, the server moves me and then responds, hey, you've moved, then there's going to be a lot of lag between when I press a button and when my player moves, right? Well, exactly, and that's where client-side prediction comes into play. Client-side prediction means that when the client does an RPC call, they also do whatever they just asked the server to do on their own machine without waiting for a response. Then, when the server responds, the client updates their predicted values with whatever the server says. If everything goes as expected, they will both have the same values and the client won't notice that anything changed. But if for any reason the server responds with different values than what the client predicted, then the client will update their own values with what the server says, and the player might see a jitter. Great, so that's very high level what networking looks like in Unreal Engine. Of course, there's a lot more I haven't discussed, but now we can answer the question, what does gas do in this whole setup? Well, gas does some things out of the box for you, like handle RPC calls for activating abilities. So when you press a button and you activate an ability, gas will automatically do that on both the server and the owning client. It also does client-side prediction. Part of the ability runs on the client, part of the ability runs on the server, and gas handles synchronizing them if for any reason they are not. And it also handles replication out of the box for things like gameplay effects, cues, and some attributes. Now, with all that in mind, we are ready to tackle our actual problem with equipping our weapons in multiplayer. Alright, first to fix our multiplayer problems, let's run our game in multiplayer and see what they are. To do that, we go over here in the play mode and down under number of players. You can set like 2 or 3 or something like that. And here you can either set it as listen server or play as client. Listen server means there will be one player who's a server and the other is the client in the case of 2 here. Play as client means all players will be clients and the server will be running in the background, not as a player. So we'll do listen server, and I'm going to go under any blueprint and play to open it in full screen. So now I have this guy who's the server, and I have this guy who's the client. So let's see what happens when I equip a weapon on the server first. So if I equip it on the server sees the weapon fine, And to the server, everything's okay. And same on the client. If I equip my weapon on the client sees it fine, and to the client, everything's okay. But the client doesn't see the server's movement settings and weapon config. So the client sees the server's weapon, but not the other properties. Now, the server sees the client's properties just fine. Why is that? Well, the reason is right now when we run our ability, the ability will run on both the server and the owning client. That's what running gameplay abilities does. So when we send the gameplay event, this activates the ability, and the gameplay ability triggers on both the server and the client, which means that, let me actually show it to you here. Let's go to our equipment manager, and I'm going to put a print here in the equip weapon function. Okay, I'm just going to print hello. Now, if I play, I'm going to see the client here. Let me actually do it on the server first. I'm going to equip a weapon on the server, and you see server says hello. That means the server just equipped the weapon. But if I equip on the client, you see server says hello and client 1 says hello. That means that this action happened on both the server and the client. Why didn't the equip weapon on the server here happen on the client as well? Well, because the server is their owning client. The server is the one that has the character on it. So the gameplay ability will run on the server and only the owning client, but won't replicate the movement properties to the other connected clients. But how come the other client sees the weapon? Well, that's because the weapon class itself is replicated, but none of the movement properties, animations, all that's not replicated. So that we need to replicate. And there's another issue because it ran on both the server and the client. Right now, if I look at, let me detach, and I look at this player, I'd see that they have two staffs equipped. One that was equipped when the server printed hello, and one that was equipped when the client printed hello. That means we need to make sure that we equip the weapon only on the server and then replicate all the properties to the client. Let's go to our weapons manager component, remove this print, and it's actually quite simple. So like I mentioned, the spawning of the weapon and the equipping it and attaching it, this needs to happen on the server only because the weapon is replicated. Let's open our base weapon again. So if I go to my base weapon here, remember we set it to replicate. Now if I turn this off, if I turn replicates off and I play, now I equip a weapon. It's equipped on both the server and the client. Server sees it because the server is the authority. So everything spawns on the server. Now, if the server equips a weapon, it's not replicated. So it doesn't go to the connected clients. And of course, what I'm doing here as this client goes only to the server, but doesn't go to a third connected client. So let's see how we're going to fix it. Again, set the weapon back to replicates. That's very important. All right, so back here in our weapons manager component, we want to split the things that need to be done on both the client and the server in their own event, and the things that need to be done only on the server in their own event. So right here, for example, everything here needs to only be done on the server. Only the spawn, actor, and attach, this only needs to be done on the server. So everything after that, we're just going to split it. So let's take this, let's give it its own mesh. So I can cut all of these. There we go. And we can remove this. So I cut all of the weapon properties part. And let's make a new event here. On equip, let's add a custom event and say set equipped weapon properties. And we're going to paste all these things. Now, this will take the equipped weapon variable and use and then set all these properties from it. I'll show you just in a second why we're doing it as a separate event, but let's just do it as a separate event first. We get our equip weapon, make sure it's valid, because for some reason it could not be valid. And then we get our weapon config from that. And we break it. All right, so this will be our anim class. These are our movement properties, and you can hide everything else for now. All right, so now we can call this event right here at the end. So set equipped weapon properties. So we didn't do anything different. Right now, instead of just putting them directly here, we're now calling them at the end. So basically, we're not doing anything different yet. So if I play, nothing should be different. I equip a weapon on the server. The client doesn't see the right animations or movement properties yet. Of course, because we haven't replicated any of these things. So how do we replicate all these things? Well, you don't want to replicate the variables themselves, and you don't want to replicate all of the movement properties. You only want to set them on the client once the weapon is equipped. So we just need to tell the client, the connected client, hey, the weapon has changed, so set the new weapon's movement properties. And the way we do that is only by replicating this single variable, the equipped weapon variable. So we click on it, and under replication, there's replicated and rep notify. Replicated means that when this variable changes, all the connected clients will know. Rep notify means that the same thing will happen, but you now have a function that is also called when this changes. All right, so now this function was just implemented for us when we change this to rep notify. Now under this function, what I'm going to do is I'm going to check if my equipped weapon is valid. So this function just tells me that the variable has changed. So I'm going to check that the variable changed to a valid variable. Great. Then I'm going to say set equipped weapon properties. So I'm calling it again, but this time on rep notify. This only happens on the connected clients. Amazing. So the server will do all of this, including calling the set weapon properties, and then change the equip weapon variable. Once the equip weapon variable changes on the connected clients, and the connected clients will also set their own equip weapon properties. Let's play and let's see how it looks like. So now the server presses 1. Oh, that did not work. Did this happen? Oh. It did not happen. I think that is because we did not set the component itself to replicate. So under class defaults, the component should replicate as well. So now if we press 1, boom, there we go. Perfect. So this works just as we expect. There's still a few problems. Unequipping won't work because we haven't changed anything. So if I press 1 again, you see the movement settings didn't go back. Still doing the old animations. And we still have the issue of equipping 2 weapons. But let's first handle unequipping first. So under unequip, we want to do the same thing. All of these things that we do, all of these movement settings, we also want to keep them in a, right here. We want to keep them in a separate event. The server will just destroy the actor. And once the server destroys the actor and sets the equip weapon variable to nothing, it will also trigger the onRep equip weapon. So let's take all of these things again and cut them. Oh, I also want the unarmed weapon config. Let's take all of this. And we're going to create a new custom event. We are going to call it set unarmed weapon. It's not a weapon, but we're calling it that. Set unarmed weapon properties. All right. And again, here we just call it set unarmed weapon properties. Great. So now we see this will trigger the same onEquip weapon onRep notify. And then this branch will be triggered. So here we want to say set unarmed weapon properties. Let's test it out. So now on the server, I equip a weapon, client sees it, unequip a weapon, client also sees it. Client equips a weapon, server sees it, client unequips a weapon, server also sees it. But now I have 2 weapons in my hand. So this is the issue that we still need to fix. Now, there's a simple fix for that. I mentioned, again, we spawn 2 weapons. Let me again show you here. In the equip weapon function, we spawn 2 weapons. Let me print. Because it's printed twice on the client. So the server only has 1 weapon, because on the server, we're only calling equip weapon once on the server. On the client, though, we call equip weapon twice. Look at the print. Once on the server and once on the client. So the client spawns their own weapon as well, and then the server responds, hey, here's your new weapon. Now, the client just overrides the equip weapon variable, but they don't do anything about the weapon that they spawned themselves. Now, if you want client-side prediction, you can have the client spawn their own weapon, wait for the server to respond. Once the server responds, the client destroys the weapon that they created. This if you want to remove any lag between pressing equip and receiving the weapon. But for equipping a weapon, it's not an action that you want to happen instantly. It's not something that critical, such as movement or shooting, for example. So we're not going to do client-side prediction. Instead, we're just going to say this happens only on the server and the client waits for it to happen. Very simple. So in the beginning of the function, what we can say, we can do something called switch has authority. So this is the branch. It checks where is this code running. Is it running on the server? That means authority. Or is it running on a connected client? So if it's running on a connected client, we're not going to do anything. We only want to run this function if it's a server calling it. So now if we play, I press 1, server sees my weapon, client sees my weapon, press 2, this still works. Back here, press 1, press 2, excellent, the weapon gets destroyed correctly. And if we want to validate absolutely that it's working, let's play it here. So let's equip the staff. And whoops, and let's go here. Let me just move that. I'm gonna click on this guy and see, yep, he only has one staff equipped. Let's have him equip an axe now. Go back here. He only has one axe equipped. Perfect. So we don't perceive almost any latency, right? Like we press 1 and it happens instantly that we see the weapon equipped. So let me show you just when I'm pressing 1 here, and almost instantly. This is because we're simulating fairly good internet. If there was slow internet, you'd press 1, wait a second for the weapon to equip on the server, and then get sent back to you. So we don't really need client-side prediction for this, even if it's bad internet. Usually it's fine for something as critical as equipping a weapon to make sure that it first happens on the server. All right, and just to validate everything works correctly with multiple clients, we're going to equip a weapon on the server, and now both clients see it, and unequipping also works. We're going to equip a weapon on one of the clients. All clients see it, including the server. And finally, last client. Yep. So this all works as expected. Great. So what did the gameplay ability system actually help us with here in multiplayer? Well, for such a simple ability, where most of the things are happening outside of the gameplay ability system itself, it didn't help with much. The only thing it helped with is triggering the ability. So for example here, let me remove the send gameplay event and equip the weapon myself. So if I say here, equip weapon, and I call staff, let's see what happens. So right now on the server, if I equip the staff, it's going to work just fine, and unequipping works as well. But on the client, I'm pressing 1, I'm trying to equip the weapon, but nothing's happening. Now, why did it work on the server and not the client? Well, because again, we set this function to only work on the server. But doing an input action is something that's only triggered on the client. So here you would have to send the event to the server manually by creating a RPC call. So you'd create something like server equip weapon, something like that. Replicate, you'd say run on server. And then here this is where you would call the equip weapon. And then on triggered, you'd say server equip weapon. So this is basically sending an RPC call when an input is pressed to call a function that is executed on the server that now runs on the client. So this is what GAS does for us. But not only that, but GAS also calls it on the client for us. So it calls equip weapon first on the client, and then calls the server equip weapon. So it does both. And in certain cases, when you do things inside the ability itself, it handles client-side prediction for you. In this case, this is basically what it does. So we're going to see a lot more benefits in multiplayer when we move forward, especially when it comes to gameplay effects and cues and attributes that are all replicated. But for such a simple action, it didn't do much for us other than trigger it on both the server and save us an RPC call. Now, and since we're on the topic of multiplayer, let's discuss a couple more issues we have in multiplayer with the dash ability. So let me show you. If I dash now on the server, you see the cooldown triggers normally. This is the server, I'm dashing, cooldown triggering normally. But if I dash on the client, cooldown doesn't trigger and I can keep dashing as much as I want. Now, why does that happen? Well, let's open our GA dash ability. And this is because we call commit ability cooldown on a latent task. You can't commit after the ability starts or unless the ability is ending. So these are the two times where you can commit an ability on something that happens synchronously. Now, applying a root motion is an asynchronous task as a latent function, and on finish will trigger a time after what's called the prediction window of the gameplay ability has ended. Now, there are ways around it, but the simplest one in this case is not to call commit ability on finish, but instead, let's remove that, do end ability here normally, and then just call commit ability, cooldown on end ability here. So this is something that happens synchronously and on the server and the client. So this will work now. So again, server, still dash works fine. Client, now the cooldown works. Perfect. There's another issue with the dash ability, which is a lot more harder to solve, but let me show you. It's the dash direction. If you recall, before I show it to you, the dash gets its direction like this. It gets the last movement input vector, and if that is a 0 vector, then it falls back to the forward vector of the actor. So it looks something like this. If I am moving forward and I dash, then I dash forward. If I'm moving backward and I dash backwards, right? Everything works fine on the server now. If I'm moving left or right, I dash left or right. This is not the case on the client. If I'm moving forward and I dash, perfect, works great. But if I'm moving backwards and I dash, it still dashed me forward. And you saw there was a lot of jittering. This is the client-side prediction that I was telling you. The client is trying to do something, the server is doing something else, and the server is updating the client. So let me show it to you in slow motion. I'm going to dash backwards and try to dash. You see here, there's back and forth. The server is fighting the client. Now, this is because the last movement input vector here is valid only on the client. This is not a value that exists on the server because it's related to your input. And the input is something that only exists on the machine of the player. So it's defaulting always to the forward vector. That means that the client is trying to do one thing, dash forward. The server is doing something else. Sorry, the client's trying to dash backwards, the server is trying to dash forwards, and there's a mismatch. So usually a solution here is not to get a input value directly from the ability. It's instead to pass it to the ability on activation, like we saw with the equip weapon. So let's open our GA equip weapon again. And we saw here that we equip a weapon from an ability, and then we send it some tags, and then we use that, right? So we're going to do the same thing for the dash ability. We're also going to activate it from an event and pass the dash direction. So let's see how we're going to do that. Back in our Nexus player here, this is where we activate our ability. We still do the activate by class. So we're going to remove that. And we're going to instead send a gameplay event to actor. So just like we did with the weapon, the actor is ourself. The event tag, let's create a new event for it. We named this one event.weapon.equip, but actually I want a new name for ability activation. So something like event.activateAbility.dash. Let's actually rename this event.weapons.equip to the same thing. I like it more. Event.activateAbility.equip weapon. I think it's then all of the ability activation events are under a single tag. Just gonna detour real quick to change that for the equip weapon. Class defaults, activate ability, equip weapon, and we just need to change it here as well. Equip weapon, activate ability, and equip weapon, activate ability. All right, I think now I can compile all these and I can delete manage gameplay tags and delete this weapon equip delete tag. Yes, great, perfect. So all of our ability activations are under this one tag. And here we can call our dash activate ability. Now for the weapon, we passed in, so I pull off the payload and say make. For the weapon, we passed in data in the tags because we just needed a tag to pass. But now we need to pass a vector. Unfortunately, there is no vector parameter in the event data, but there is this target data. So let me just keep only the target data. And the target data, you can create a hit event out of it. So pull off and say ability target data from hit results. So if you didn't see what I searched for, I just searched for hit and it was the only one. So this takes a hit result and passes it as target data. Now for the hit result, we can pull off and say make hit result. And if you're familiar with any hit trace, it gives you all of these things. We're only interested in the location, or really any vector parameter, but we're going to encode the dash direction in our location. So we're going to say get last movement input vector. And that is it. We can then collapse this, and let me just clean this up a bit here. And then this will be our ability activation. All right, just sends the event and passes the last movement input vector encoded in a hit result. Now in our dash ability, we don't need this get dash direction function anymore. I can delete it and delete it from here. Now instead, what we're going to do is we are going to override the activate ability from event. This is the event that we're going to be using now instead. And of course, this gives us our event data, which we can pull off and break it. And from the event data, we can get our target data and say, search for hit result as well. And say target, sorry, not this one, not target data has hit results. Get hit result from target data. So this is the hit result that we want. We can pull off of this one, say break, and get our location. Right? So this is the location that we passed here as our last movement input vector. And because it's passed in with the activation of the ability, then it will be available on both the server and the client. Because it's not something that the ability checks for on the server. No, it's something that is sent from the client, because the client does the input, and it sends it to the activation event on the server. So then it's going to be available on both. But let's do a check first that it is not 0. So do a select vector here. Get the location again, and check if it is equal to 0. So if this is equal to 0, then we want to use the actor's forward vector. So get the avatar actor from actor info and get the actor forward vector. So it's the same fallback. We fall back to the forward vector if the location is not valid. And if it is valid, then use that. All right, that's basically it. Just cleaning things up a bit. And I believe this should work. Let's test it out. So now I'm going to try to dash backwards. Well, I'm not dashing. We forgot to add the activation trigger. Under class defaults of our GA dash, under ability triggers here, we need to add what event triggers this ability. So of course it's event activate ability dot dash. And now it should work on my client. Equip this so I can move backwards and dash backwards. Perfect. Dash forwards. Perfect. Dash in any direction. It works. Go to my server. Dash left. Perfect. Dash forward. Now it works on both server and client. So that's one way to pass data to, well, another way to pass data to an ability. There are multiple ways to pass data. This is the best one because it's passed together with the ability activation. So you're ensured that this value will be available on both the server and the client. Now, if you want to pass in more complex data, I mean, now we had to encode it in the hit results, which might not be the cleanest thing because, I mean, dash direction isn't really hit location. So we just decided that this is the case. If you want it to be more cleaner, the event data does offer something called optional object and optional object 2. This can basically be any actor. So you can create an actor that has like a struct on it, and it's just a lightweight actor that you pass around when you activate abilities. So you create this actor, could be a data asset, you set a value on it, and then you pass it. It's a bit cleaner because then you control the exact data that you want, but it's slightly heavier on memory because you actually have to create an actor or create an object and spawn it. It doesn't have to be an actor, but an object spawned in memory. But I think the memory usage will be negligible if you don't create a big actor or object. So you have the option, you can choose which one you want, but this is how you fix the dash direction problem. And that's it, our Nexus game is now multiplayer ready. We've took what we learned about replication and authority to turn our weapons manager component into a networked component. We also learned how to pass data to our gameplay abilities so that they're available on both the server and the client. And for Patreon members that are following along with the extended weapons manager component, the one with all the animations and the stow logic and all that extra features, I'll be uploading a dedicated video showing you how to turn that into a multiplayer ready component as well. Now in the next part, I will be showing you how to add and remove gameplay abilities at runtime, so that when you equip a weapon, you gain new abilities, when you unequip it, you lose those abilities. And we will make it all work cleanly in multiplayer. Now, this part of the series was a turning point, because from now on, everything we build, we will make sure that it works in multiplayer as well. I hope. Now, if you're watching this, then you've made it to the end of the video, and you've probably been with me from the beginning of the series, and I don't know for how long before that. So I just want to take a moment and say thank you, truly from the bottom of my heart, thank you. You don't know what it means to me to be able to make these videos and see this level of engagement and support. Now, it takes so much time and effort to make these videos, but I'm always happy because I know that you will be there learning something new and building something cool. So keep it up, and hopefully I will see you in the next one.